In this video, I'd like to introduce three concepts that we'll be frequently talking about whenever we talk about online multiplayer games. These three concepts will come up when we talk about architectures, either client-server or peer-to-peer architectures. They'll also come up when you're developing your games, and you should keep these three concepts in mind as you're sort of designing the gameplay experiences and as you're developing the gameplay systems. The first concept that I'd like to introduce is called authority. Authority describes which client has the ability to say what the current state of the simulation is. This isn't a suggestion. This is who is it that breaks the ties. When two different clients think that two different actions happened, who is it that has the authority to act as the judge on who actually crossed the finish line first? Or did you duck, or were you hit by that bullet before you ducked around the corner? The second concept I want to talk about is ownership. Ownership is the idea of who has control of specific objects in the game. I'm controlling a player, and you're controlling a player, and it'd be a little weird if I could send position updates telling the server or telling other players in the game where you are moving. So that's the idea of ownership. You typically own the objects, you own your own player, you own the objects that you are interacting with, and ownership of objects can kind of be shuffled around, right? But it is very important to have an understanding of who owns which objects, and as a programmer to know and be very clear about where that ownership lies. The third thing is this idea of a host. A host, which is a very common term, we hear this all the time when we talk about online games. The host is sort of the machine that is responsible for facilitating the network traffic, for setting up the game, for establishing the connections between the various players, and allowing other players to connect to one another and potentially handling the traffic that goes between them. These three concepts can all happen on the same machine. They could all happen on a different machine. They could be distributed between different machines. As one example, say we have a server and we have two clients. We could, in a very common model, establish that this is an authoritative server. What that means is that this server is controlling exactly the state of the game. And when I say that I crossed the finish line and another person says that they crossed the finish line at the same time, the server is the one who has the authority to decide which of us won the race. In this same example, on our clients, we may be seeing something like this. I have a red car, and I'm at this position. And you can also see my car on your machine. And you have a blue car, and you're out in front, right? And we're heading in this direction, right? And you're seeing something very similar. The blue car is out in front, and we're heading in this direction, right? Now, in this case, client one over here, I'm in control of the red car. I probably own the position of where this red car is. When I turn left, when I turn right, when I accelerate, when I apply the brake, I'm the one who owns the red car, so I'm the one who's telling the server how I'm moving and the behavior of my object. You own the blue car, so you are controlling and have ownership of the blue car in this simulation. You're deciding when to apply the throttle and the brake, turn left, turn right. And it'd be strange if there was a time where you were sending updates about how I was applying the brakes in my car, or if you were sending updates about how I was turning. That's where this idea of ownership comes in. I would own the red car, you would own the blue car. And because of this, and because of how we've written the code behind our game, we can very easily determine who has control of which objects, who should be sending which messages, and we can base that just based on the gameplay, right? The third thing is the host of this game. Now, for a lot of online multiplayer games, this idea of a host is sort of transparent to a lot of people. I may invite you into my game, or you may invite me, and there may be a server in the architecture, the network architecture that we're using, or there may not be. This may be a peer-to-peer setup, right? So sometimes when you're playing a game, it's a little ambiguous on who is the host in this situation. Other times, it's incredibly clear who the host is, and I may be hosting the game, which may also make me the authority and owner of all of the objects in this simulation. And other players may be connecting to my client as the host. And we've all heard this phrase of the host having an advantage, this host advantage. That typically comes down to the fact that I am the authority and owner of these objects, and at the same time, I'm running my own simulation. So what I see on my client is 100% accurate compared to what you are seeing, which is delayed by the network traffic going on. Right? So these are the three concepts, and as we go forward through this course, I imagine that these three topics will come up many times. You should be thinking about these three topics as you're developing your projects. You should be thinking about these three topics as you're talking about different network architectures and how you're writing the gameplay code for your game. The authority, who can decide what is actually happening in this game. The ownership, who is it that's deciding how objects move or behave. And then the host, on who is creating the overall experience, who's inviting other people into this game, who's facilitating the connections that are going on.